Hi all, welcome to Go Classes daily practice questions of discrete mathematics. In this session we are going to solve a standard question from predicate logic. This question is taken from Stanford University. So let's see this question. The question is saying that consider the following diagram. A graph is given to you. You can see this graph. Now the question is saying that if there is an arrow from person X to person Y, then it means that person X loves person Y. We denote this by this predicate loves X comma Y. So loves X comma Y, this means X loves Y. So in this question we are saying that if there is arrow from X to Y, if there is arrow, then it means X loves Y. For example, you can see in this graph, you can see there is arrow from P4 to P3. So I can say P4 loves P3. But you can notice there is no arrow from P3 to P4. There is no arrow. So it means P3 does not love P4. So the question is saying that, for example, loves P4 P3 means P4 loves P3. Why? Because there is arrow from P4 to P3. So P4 loves P3. Also loves P5 P5 means P5 loves P5 because there is arrow from P5 to P5. It means P5 loves P5. Next, you can notice but not loves P4 P1 because you can see there is no arrow from P4 to P1. So it means P4 does not love P1. Now the question is saying that there is no implied arrows, means these are the arrows that are given to you and there is no other implied arrow. What it means? It means that P1 loves P3. This is, you can see there is arrow from P1 to P3. So this arrow you have, it means P1 loves P3. But you can see that P3 loves P2. Yes, because there is arrow from P3 to P2. So P3 also loves P2. But you can see the statement P loves P1 P2 is false. What this means? Because you can see there is no arrow from P1 to P2. From P1 to P2 you can see there is no arrow. There is no arrow between from P1 to P2. So I can say loves P1 P2, that is false because P1 does not love P2. So I can say loves P1 P2, that is false because there is no arrow from P1 to P2. Similarly, even though P4 loves P3, you can see because there is arrow from P4 to P3. So it means P4 loves P3. But you can notice loves P3 P4, that is false. Why? Because there is no arrow from P3 to P4. So it means loves P3 P4, that is false because P3 does not love P4. Okay, so there is no arrow from P3 to P4. It means this loves P3 P4. What it means? It means P3 loves P4, that is false because P3 does not love P4 because there is no arrow from P3 to P4. So this is the question. I hope you understood the question. Now the question is saying that below is a series of first order logic statements. So some first order logic statements are given to you. So you have to tell us which of them are true, which of them are false. So some first order logic statements are given to you. These are the first order logic statements. These are also given. Total 16 statements are given to you. Now you have to find out which are true, which are false. Also remember, if something is false, if a statement is false, you can see for each false statement, you have to tell the smallest collection of arrows that need to be added to make it true, to make that statement true. Okay, so the question is saying if a statement is false, for example, you can notice this statement. Look at this statement, loves P3 P4. This statement is false because P3 does not love P4. You can see loves P3 P4. What it means? It means P3 loves P4. That is false because P3 does not love P4 because there is no arrow from P3 to P4. So I can say this loves P3 P4. This statement is false. So what you need to do, for each false statement, you need to tell us what is the smallest number of arrows that you need to add in the diagram so that that statement becomes true. So here I can say, if you want to make this statement true, then what you need to do? Very simple, one arrow you need to add. In this diagram, this arrow you need to add. So I can simply say that for each false statement, you need to tell us how many minimum number of arrows you need to add in the diagram to make that statement true. For example, if you want to make this statement true, then you need to add one additional arrow. One arrow you need to add from P3 to P4. From P3 to P4 you need to add this arrow. Okay, this arrow you need to add if you want to make this statement true. So this is what the question is saying. So I hope this is clear to you. So a series of first order logic statements are given to you. So these statements, also these statements, total 16 statements are there. You need to find out which of them are true, which of them are false. And if a statement is false, see, if a statement is true, you simply say that it is true. But if a statement is false, then what you need to do? You need to make it true. And to make it true, you need to add some additional arrows in the diagram. You need to make some additional love relations. Okay, so very simple. So this is the point. So for each false statement, you make it true by adding minimum number of arrows in this diagram so that this false statement becomes true. Okay, and you have to answer what is the minimum number of arrows you need to add and from where to where. So I hope this question is very clear to everyone. So this diagram is given to you. You can see this diagram on your screen. Okay. So you just try this question. Now let me make sure that you understand this question. So let me tell you that in this question, first of all, the domain contains total 6 elements. So let me tell you that in the domain you have total 6 elements. There is P1, there is P2, P3, P4, P5, P6. So there are 6 elements in the domain. So the domain is finite. In the domain you have total 6 elements, P1 to P6. These are the elements. Now on this domain you are defining a predicate. This predicate you are defining. You are saying that loves x comma y. This predicate you are defining, and this predicate means x loves y. Now the question is saying that if there is arrow from x to y, that means x loves y. Okay, so the question is saying that if, for example, I can say if A loves B, then how we show this in the diagram? If A loves B, then it simply means we write like this. We create the diagram like this, that A loves B. So if A loves B, it simply means that loves A comma B is true. So I can say if this is true, if loves A comma B, this is true, then what we do? We create this type of diagram, we create that A loves B. And also remember, if you have this type of diagram, that there is arrow from A to B, then what it means? It means that A loves B. It simply means that A loves B. I hope this point is clear to everyone. So for example, if you have this type of situation, if you have this type of diagram, if you have this type of arrow from A to A, that simply means that A loves A. And if there is no arrow from A to B, for example, let's assume there is arrow from B to A, but there is no arrow from A to B, it simply means that B loves A because there is arrow from B to A. So it simply means that B loves A. But remember, because there is no arrow from A to B, it simply means that A does not love B. A does not love B. So this is what this diagram means. I hope this point is clear. So remember, in this question, the domain has 6 elements, P1 to P6, and this predicate is given to you. This is x loves y. Loves x comma y, it means x loves y. Okay, and remember, this love, this is not symmetric, because you can notice, for example, P4 loves P3, but P3 does not love P4. There is arrow from P4 to P3, so it simply means that P4 loves P3. You can see there is arrow from P4 to P3, there is arrow. What it simply means? It simply means that loves P4 P3, that is true, means P4 loves P3. But you can notice there is no arrow from P3 to P4. From P3 to P4, you can see there is no arrow. So it simply means what? It simply means that P3 does not love P4, or I can say loves P3 P4, that is false, because P3 does not love P4. So I hope this question is clear to everyone. You can see P5 loves P5. You can notice P6 does not love anyone. P6 does not love anyone. P6 does not love itself also. So you can see, for example, in this question, you can see that this P6 does not love anyone. For example, if you ask P6 loves P6, that is also false. P6 loves P6, that is also false, because you can notice there is no arrow from P6 to P6, but there is arrow from P5 to P5. So it means P5 loves P5. So I hope this question is clear to everyone. Okay, so now what you do? Very simple. This diagram, this graph representation is given to you. Basically this graph, you can notice this graph. This is interpretation of this predicate loves x loves x comma y. Okay, so remember this graph, this is interpretation of the predicate. This graph is telling you who loves whom. From this graph you can notice P1 loves P1, P2 does not love P2. You can notice P2 does not love P3. You can notice P2 does not love anyone. You can notice P6 does not love anyone. P5 loves P5. P4 loves P3. P4 does not love P4. So very simple. Now what you need to do, for all these first order logic expressions, you need to tell us which of them are true. And if any of them is false, for example this is false, then you need to tell us how many minimum arrow you need to add in this diagram to make it true. For example, if you want to make it true, then you will add this arrow. Similarly, you can notice, for example, let's see this one. You can see is this true? Yes, this is definitely true, because you can notice this loves P1 P2. This itself is false. False implies anything that is true. So this 6-1, this is a true. I hope this question is clear. So these are some more expressions that are given to you. You need to tell us which of them are true, and if any of them is false, then you need to make it true. For example, let's assume this is false. Then you need to find out how many minimum arrows you need to add in this diagram so that this becomes true. Now let's solve this question. So this graph is given to you, and this graph is telling you who loves whom. So this graph is basically the interpretation of this loves predicate. So this predicate loves x, y. This says x loves y, and this graph is basically the interpretation of this loves predicate. Means this graph is telling you who is loving whom. So now let's see which of these statements are true, which of these statements are false. So let's see the first statement. Loves P1 P3. Is this true? So can I say that P1 loves P3? Yes, because there is arrow from P1 to P3. So I can say yes, this P1 loves P3. This statement is true. What about the second statement? Loves P3 P4. This statement is false, because you can notice that this statement is saying that P3 loves P4. But you can notice there is no age from P3 to P4. So I can say P3 does not love P4. So finally I can say this statement is false. Now because this statement is false, so how can I make it true? What I need to do to make it true? What is the minimum number of arrows I can add in this diagram so that this statement will become true? What is the minimum number of arrows? So what I can do, very simple. I can simply just add this arrow from P3 to P4. If you add this arrow, then automatically what will happen? This statement will become true. So remember, finally I can say that this is what I can say, that this statement is false. This statement is false, but what you can do, you need to add one arrow. We need to add one arrow, and this arrow we need to add from P3 to P4. This arrow we need to add. Okay, so I can say this arrow we need to add. If you want to make this statement true, then minimum one arrow you need to add. So this arrow you need to add if you want to make this statement true. Remember, this is the minimum number of arrows you need to add. Of course, what you can do, you can do this. You can add two arrows also. For example, you can add these two arrows. You can add this arrow also. Now, if you do this, if you add these three arrows, then also this will become true. This statement will become true, because you can see P3 loves P4. But the point is, what is the minimum number of arrows we need to add in this diagram so that this statement will become true? So the minimum number of arrows is only one. What you do, you add this arrow from P3 to P4. So the answer will be that this statement is false, and we need to add one arrow from P3 to P4 to make this statement true. Now let's see the next one. What about this next one? This loves P1 P2. Is this statement true or false? You can see there is no arrow from P1 to P2. So this statement is false. Now you can see this loves P2 P1. This statement is also false, because there is no arrow from P2 to P1. So this statement is also false. False and false, that is false. So I can say this third statement, this is also false. So how can I make it true? What is the minimum number of arrow you need to add in this diagram to make this third statement true? So we need to add two arrows. If you want to make this third statement true, this statement, remember, there is conjunction here. So if you want to make this conjunction true, then you need to make this statement true, and also you need to make this statement true. So what I can do, I can simply, so remember there is and here. So that is the reason I can simply say that to make this third statement true, minimum you need to add two arrows, one arrow from P1 to P2 so that this statement becomes true, and one arrow from P2 to P1 so that this statement becomes true. So remember, in this third question, the answer will be two arrow we need to add. So in this question, I can simply say that we need to add total two arrow. We need to add one arrow from P1 to P2 and another arrow from P2 to P1. So this is your question number third. Now let's see the next question. The next question is saying this loves P1 P2 or loves P2 P1. So this statement is also false. We can see that because you can notice this allows P1 P2. You can see there is no arrow from P1 to P2. So this statement is false. Also there is no arrow from P2 to P1. So this statement is also false. False or false, that is false. So ultimately I can say this fourth statement is also false. Now if you want to make this true, because remember there is OR here. Now you have OR here. So if you want to make this fourth statement true, then what is the minimum number of arrow you need to add in this diagram? So if you want to make this fourth statement true, then either you can make this true or you can make this true. So what you can do, you just need to add one extra arrow. Either you can add this arrow or you can add this arrow. One arrow you need to add, and then this statement will become true. So remember, if you want to make this fourth statement true, then minimum number of arrow that you need to add, that is 1. So I can say in this statement, I can say only one arrow you need to add. Only one arrow, that is enough. One arrow from P1 to P2, this is enough. Or you can add arrow from P2 to P1, that is enough. Minimum one arrow you need. So that is the answer. Either you can add from P1 to P2 or you can add from P2 to P1. So this is the answer for this question. One arrow either from P1 to P2 or from P2 to P1. But the point is only one arrow is needed. Now let's see the next. Now let's see this fifth one. This is saying that loves P1 P1 implies love P5 P5. So in this you can notice loves P1 P1. P1 loves P1. That is true because there is arrow from P1 to P1. So I can say this is true. Loves P5 P5 means P5 loves P5. This is true because there is arrow from P5 to P5. So this is true. True implies true. That is true. So I can say this fifth statement, this is a true. What about the next? This sixth statement, you can see this is saying loves P1 P2 implies love P4 P3. So you can see this loves P1 P2. This itself is false because you can notice P1 does not love P2. There is no arrow from P1 to P2. So P1 does not love P2. So I can say this loves P1 P2. This itself is false. And this loves P4 P3. This is true because P4 loves P3. False implies true. That is a true. So I can say this sixth statement, this is also true. Now let's see this question number 8. So in this we are saying loves P1 P4. You can see that P1 does not love P4. There is no arrow from P1 to P4. So I can say this loves P1 P4, that is false. And this is saying loves P4 P5. This is also false because there is no arrow from P4 to P5. So this is also false. False implies false, that is true. So this statement 8, that is also true. What about statement 9? This is saying that loves P1 P4. So you can see P1 does not love P4. You can see there is no arrow from P1 to P4. So this statement is false. What about this statement? Loves P2 P3. You can see P2 does not love P3 because there is no arrow from P2 to P3. So this statement is also false. False by implication false. That is true. So I can say this statement is also true. Now let's see this seventh. So this is saying loves P1 P3. You can see P1 loves P3. So I can say this statement is true. And this loves P3 P6. This statement is false because you can see there is no arrow from P3 to P6. So this P3 does not love P6. So this statement is false. True implies false. That is false. So I can say this seventh statement is false. But how can I make it true? If you want to make this true, this seventh statement, if you want to make this true, then what is the minimum number of additional arrow you need? In this diagram, what is the minimum number of arrow you need to add so that this seventh statement will become true? So you can see in this diagram, all you need to do, just make sure that P3 loves P6. If you want to make sure that this seventh statement becomes true, to make this seventh statement true, what you need to do? You need to add only one arrow, that is from P3 to P6. So this arrow, if you can add this arrow, then this seventh statement will become true. So remember, to make this seventh statement true, all you need to do, just add this additional arrow in this diagram. Remember, you cannot remove this arrow. Don't say that just remove this arrow. Okay, if you remove this arrow, then also this seventh statement will become true. But the question is asking that you should add additional arrow. You cannot remove the arrow from the diagram. Okay, so if you remove this arrow from the diagram, then also this seventh statement will become true. But the question is saying that what you can in this diagram, what is the minimum number of additional arrow? You can add arrow. minimum number of arrows you can add to make this statement true. So finally I can say that this seventh statement I can make it true. All you need to do is just one arrow needed. One additional arrow is needed, that is from P3 to P6. So if you add this arrow, then this seventh statement will become true. Let's see this statement number 10th. So this is saying that loves P1 P3. You can see, yes, because of this arrow I can say that P1 loves P3, this is true. Loves P5 P5, yes, this is also true. So I can say that true by implication true, that is true. Now let's see these expressions one by one. So which of them are true, which of them are false, and if some of them are false, then how can you make them true? By adding additional arrow in this diagram. Okay, so let's see one by one. Let's see this one, 11th question. This question is saying that for every x there is a y such that loves x comma y. So we are saying that for every x, remember the domain of x is P1 to P6, P1, P2 and so on P6, this is the domain of x, and the domain of y is also P1 to P6, P1, P2 and so on P6, and we are saying that for every x, for everyone, there should be someone, for every x, there should be someone such that x loves y. It means that for everyone, there should be someone whom they love. Okay, I can simply say that x loves y. So everyone loves someone. This is the simple point. I can say this for all x, there exists y loves x comma y. This simply means that for every x, whatever x you take, there should be someone. For example, maybe this x loves this y, this x loves this y, this element loves this element, and maybe this element loves this element. So the point is that for every x, for every element, there is some element. For everyone, there is someone such that x loves y. I can simply say, here I can simply say that x loves y. So what it means? It means that everyone loves someone. Everyone loves someone. For everyone there is someone whom they love. I can simply say, it simply means that everyone loves someone. Everyone loves someone. So this is the simple point, that everyone loves someone. Now let's see, is this statement true? Can I say in this diagram, can I say that everyone loves someone? You can notice P1 loves P1. Yeah, that is fine. Okay, so I can say P1 loves P1. Very good. So P1 has no problem. P1 loves P1. You can also see P1 loves P3. But the point is, everyone loves someone. Everyone loves at least one person. You can notice P1 loves P1. You can notice P4. This P4 also loves P3. You can notice P5 also loves P5. You can see. So this P5 loves P5, P4 loves P3, P1 loves P1, P3 loves P2. So that here it is fine. But you can notice P2 does not love anyone. P2 does not love P2 also. So you can easily notice that this statement is false. Why this statement is false? Because remember, this statement is saying, this 11th statement is saying that everyone loves someone. This statement is saying everyone loves someone. But this statement is false. Why this statement is false? And who is the counter example? This statement is saying everyone loves someone, but this statement is false. And who is the counter example? You can see the counter example is P2, because P2 does not love anyone. P2 does not love P3, P2 does not love P1, P2 does not love P2 also. So this P2 does not love anyone. Similarly, this P6 does not love anyone. So finally I can say the counter example is P2, P6. These are the counter example. They don't love anyone. So I can say this 11th statement is false, because the 11th statement is saying that everyone loves someone. Okay, for everyone there is someone whom they love. So I can simply say that everyone loves someone. But you can notice this statement is false and the counter example is P2, P6. So how can I make it true? So this statement, we have seen that this statement is false. Okay, because and the counter example is P2, P6, they do not love anyone. So now tell me, what is the minimum number of arrow you need to add in this diagram so that this statement will become true? Remember, if you want to make this statement true, then you need to make sure that everyone loves someone. If you want to make this statement true, then you need to make sure that P2 loves someone and P6 also loves someone. So remember, if you want to make this true, I can say, to make this statement true, what is the minimum number of arrows? What is the minimum number of arrows we need to add? Needed to add. in this diagram, what is the minimum number of arrows you need to add in this diagram so that this statement number 11th, this will become true. So that will be true. You need to make sure that P2 loves someone, and you need to make sure that P6 loves someone. Remember, this you can do in many different ways. What you can do, maybe you can do this. Maybe you can make sure that P2 loves P1, and you can make sure that P6 loves P6. So this also will do. The point is 2 arrows are needed. Minimum 2 arrows are needed. Okay. So the point is simple. If you want to make this statement true, then minimum 2 arrows you need to add. Now these 2 arrows you can put, for example, you can do this. Maybe you can say that, okay, P2 loves P6, and you can say that maybe P6 loves P4. So this also will work. But the point is, minimum 2 arrows you need. 1 arrow from P2 and 1 arrow from P6. So 2 arrows you need. If you want to make this statement true, then you need 2 arrows, one from P2 to someone and another from P6 to someone. So 2 arrows you need, one from P2 and one from P6. Now let's see this next statement, the statement number 12th. This is saying for all x there exists y such that y loves x. So first of all, what it means, remember here, you know that domain of x, that is P1 to P6. So this is the domain of x, and this is the domain of y, P1 to P6. This is the domain of y. So now we are saying that for every x, for everyone, there is someone such that y loves x. Here you can see that y loves x. So let's see what it means. Remember, we are saying that for everyone, there is someone such that y loves x. So it simply means that for everyone, like if you take anyone, for example, if you take this A, then there is someone, maybe you can take this B. So I can say this is the domain of x, this is the domain of y. I can say that for everyone, for example, for this, there is a someone such that y loves x, such that B loves A. So here what I can say that A is loved by B. So in this, basically that is same as I can say that A is loved by B. Okay, because B loves A, I can say A is loved by B. So it simply means that for everyone, there is someone such that this Y will love X. I can say that everyone is loved by at least one person. Means, remember, everyone, you take anyone, this person M will be loved by someone. Okay, so here what will happen? This N will love M. So I can say this M is loved by N. So I can say everyone is loved by someone. So remember this statement. For everyone, you are saying there is at least one person who loves this X. For every X, I am saying there is at least one person who loves X. So I can say everyone is loved by someone. Everyone is loved by someone. Okay, for everyone, there is someone who loves them. Means I can say everyone is loved by someone. So you can see this statement means for all x there exists y such that y loves x. It means everyone is loved by someone. For example, this P1 is loved by P1. I can say P1 is loved by P1. What about this P3? P3 is loved by P4. So I can say this P3, this is loved by P4. You can notice P4 loves P3. Remember, here we are saying that for all x we are saying there exists a y such that y loves x. Means it means that this P3 is loved by P4, or I can say P4 loves P3. You can also notice that this P4 is not loved by anyone. This P2 is loved by P3. So I can say this P2, this is loved by P3, or I can say P3 loves P2. Okay, you can notice P5 is loved by P5. This P6 is not loved by anyone. Okay, so this is the point. You can notice this P4 is not loved by anyone, and this P6 is not loved by anyone. So what about this statement? What about this statement? This statement, you can easily notice that this statement is false. The simple reason, because this statement is saying that everyone is loved by someone. Remember, this statement is saying that everyone is loved by someone, and this statement is clearly false. Why this statement is clearly false? And who is the counter example? The counter example is, I can say the counter example is P4, P6, because this P4 is not loved by anyone. No one loves P4, no one loves P6. So remember this statement, this 12th statement, you can see this 12th statement is saying that everyone is loved by someone. But you can notice this statement is false because no one loves P4, no one loves P6. This P4 is not loved by anyone. This P6 is not loved by anyone. You can notice P4 does not love P4 also. P6 does not love P6 also. So finally I can say this statement is false. Now, to make this true, what you need to do? If you want to make this true, what is the minimum number of additional arrows you need to put in this diagram so that this statement will become true? So to make this true, what you need to do? You need to make sure that someone loves P4 and someone loves P6. So what you can do? Either you can do this, maybe P4 loves P4, P6 loves P6. This will also work. But the point is, to make this true, you need two additional arrows. You need to add minimum you need to add two additional arrows. You need to add, okay, one arrow from someone to P4 and one arrow from someone to P6. So remember, you need to add minimum two arrows, one arrow from someone to P4, someone should love P4, and one arrow from someone to P6, means someone loves P6. So what you can do, maybe you can do this. For example, P4 loves P6. This will also work, and this will also work. Like I can say this P4 loves P6. This will also work. And you can notice someone, so you can notice this P6 is loved by P4, but you need to make sure that P4 is also loved by someone. So maybe P6 loves P4. This will also work. But the point is that you need two arrows you need if you want to make this true. Or what you can do this, maybe P1 loves P4, and what you can do, maybe P3 loves P6. So this will also work. But the point is, if you want to make this true, then two arrows you definitely need. Okay, minimum two arrows you definitely need, one from someone to P4 and one from someone to P6. I hope these two expressions are clear. So these two expressions are false. Both of them are false. This is also false. This expression is also false. And to make this expression true, you need minimum two additional arrows. And to make this expression true, you need minimum two additional arrows. So now let's see the next one. Let's see this one. This expression. This expression is saying that for every one there is someone. For every x there is some y such that x is not equal to y and x loves y. So this is expression, what this expression is saying, remember the domain of x you already know, that is P1, P2, P3, P4, P5, P6. So this is the domain of x, and you can notice this is the domain of y, that is also P1, P2, P3, P4, P5, P6. So this is the domain of x and this is the domain of y. And we are saying that for every x, in this for everyone there is some y such that x is not equal to y and x loves y. Remember, loves x comma y, that means x loves y. So what this statement simply means, let me tell you. So we are saying that for everyone there is someone such that x is not equal to y and such that x loves y. So what it simply means, remember, it simply means that for everyone, you take anyone you take, for everyone there is someone. For everyone there is someone. For everyone, like you can take whatever you want. For every x there is a y such that they must be different. They must be different. X and y are different, and x loves y. Here I can say, for example, A loves B, and you can notice A is not same as B. So what it simply means that for everyone there is someone who is different from them, and this M loves N. For everyone there is someone. This T loves S. So the point is very simple, that this simply means that everyone loves at least one other person. Okay, so here I can say everyone loves at least one other person. I can simply say that everyone loves someone. Everyone loves someone other than themselves. I can say, okay, I can say everyone loves someone else. Someone else. Okay, so this is the point. I can say everyone loves someone else. So this is the simple expression. So this expression means that everyone loves someone else. Okay, everyone loves someone other than themselves. So now let's see, is this statement true? This statement, let me tell you, this statement is false. Why this statement is false? You can clearly see that this statement is saying that everyone loves someone else. And who is the counter example? You can notice this P2 does not love anyone. This P6 does not love anyone. You can notice P4 loves P3. P1 loves P3. This P3 loves P2. Okay, you can also, so here I can say that these three people, they do not love someone else. These three people, P2, P5, P6. So this expression, this is saying that everyone loves someone else. Everyone loves someone else. For example, P1 loves P3. I can say P1 loves P3. So this everyone loves someone else. P1 loves P3. You can notice P4 loves P3. This P4 also loves P3. So this P3 loves P2. This P3, this loves P2. So everyone loves someone else. But you can notice P2 does not love anyone else. You can notice P5 does not love anyone else. P5 loves P5, but P5 does not love anyone else. P6 does not love anyone else. So you can see who is the counter example. So I can simply say this statement is false. And who is the counter example? Who is the counter example? Who is making this false? So you can see that this statement is false because of P2, P5, P6. P2 is also making it false, P5 is also making it false, and P6 is also making it false. So the counter example is P2, P5, P6, because these three people, if you notice, they do not love someone else. This P5 loves P5, but P5 does not love someone else. So here these are the counter examples for this expression. Now the simple question, how many minimum number of arrows you need to add in this diagram to make this expression true? So what is the minimum number of additional arrows I need to put in this diagram so that this expression will become true? Remember, this expression is saying that everyone should love someone else. Okay, but you can notice these three people, they are not loving someone else. So you need to make sure that P2 loves someone else, P5 loves someone else, and P6 loves someone else. So you need to put 3 additional arrows if you want to make it true. So to make this expression true, this expression, we know that this expression is false, but the point is, if you want to make this expression true, to make it true, you need minimum 3 additional arrows you need. 3 additional arrows you need if you want to make this statement true. And these 3 additional arrows, remember, you need to make sure that P2 loves someone, means 1 arrow from P2 to someone, 1 arrow from P5 to someone else, and 1 arrow from P6 to someone else. So you need minimum 3 additional arrows, 1 arrow from P2 to someone else. Okay, so this you can do. 1 arrow from P5 to someone else, so this you can do. And 1 arrow from P6 to someone else, so this you can do. So I can say 3 additional arrows you need. Okay, 1 from P2 to someone else, 1 from P5 to someone else, and 1 from P6 to someone else. Remember, you cannot do this because we want P6 to love someone else. So if you put a self loop, that does not mean that P6 is loving someone else. So if you put a self loop, that is wrong. So we need to make sure that everyone loves someone else. So we need to make sure this P2 loves someone else. So you can do this also. This is also fine. This P5 loves someone else, so you can do this also. This is also fine. This P6 loves someone else, so you can do this also. This is also fine. So remember, this is also fine. There is no problem. But the point is, 3 additional arrows you need to make this statement true. 1 from P2 to someone else, 1 from P5 to someone else, and 1 from P6 to someone else. Now let's see the next. What this expression means. This expression is saying that for all x, there exists a y such that x is not equal to y and y loves x. And y loves x. So this is your expression, you can notice. So first of all, what it means that for everyone, you take anyone. For everyone, there is someone. You take for all x, there is a y. For everyone, there is someone such that a is not equal to b. They must be different, and this y loves x means this b loves a. This b loves a. So remember, for everyone there is someone. For everyone, like for a there is b such that b loves a. Maybe for m there is n such that n loves m. So very simple. And you can notice n is not equal to m. So the point is simple, that for everyone there is someone such that this loves, for every x there is a y such that y loves x. Or I can say, for everyone there is someone else who loves them. Okay, I can say everyone is loved by someone else. Everyone, you take anyone, this is loved by someone else. So very simple, I can say that this expression means that for everyone there is someone other than themselves who loves them. Okay, so I can say for every x there is at least one y other than this y is not same as x, and such that this y loves x. So I can say everyone is loved by someone else. Everyone is loved by someone else. Everyone is loved by someone else. So this expression is saying that everyone is loved by someone else. For example, you can notice this P2 is loved by P3. So I can say this P2, this is loved by P3. You can notice P3 loves P2. So this P2 is loved by someone else. This P2 is loved by P3. So this P2 is loved by P3. I can say this P3 is loved by P4, because you can notice this P4 loves P3. Or I can say this P3 is loved by someone else, that is P4. So similarly, you can notice this P2 is loved by P3. This P1 is loved by P3. So you can see, because you can see P3 loves P1. Or I can say this P1 is loved by someone else, that is P3. What about these? For example, this P6. You can see P6 is not loved by anyone else. You can see this P5 is not loved by someone else. You can notice this P4 is not loved by someone else. So these people are the counter example. You can see these people. You can see these people are not loved by someone else. Someone else does not love them. This P4. Someone else does not love P4. Someone else does not love P5. Someone else does not love P6. So these three people are the counter example. So remember, this expression is false, because this expression is saying that everyone is loved by someone else, and this expression is false. And who is the counter example? The counter example are P4, P5, P6. So I can say this P4, this P5, P6. These are the counter example. So how to make this expression true? If I want to make this expression, I know that this expression is false, but how to make this expression true? So to make this expression true, minimum 3 additional edges I need to put in this diagram. Because remember, this expression is saying that everyone is loved by someone else. Everyone should be loved by someone else. So you need to make sure that this someone else loves P4. You need to make sure someone else loves P5. And you need to make sure that someone else loves P6. So remember, if you want to make this expression true, then to make it true, minimum 3 additional arrows I need. Minimum 3 additional arrows I need to put in this diagram. Okay, 1 arrow from someone else to P4, 1 arrow from someone else to P5, and 1 arrow from someone else to P6. So this is what we need to do. Okay, what we can do, maybe we can do this. Like for example, I can say P4 is loved by someone else, P1. I can say, for example, maybe this P5 is loved by someone else, P2. And I can say this P6, this is loved by someone else, that is P5. So this is also fine. So the point is, I need minimum 3 additional arrows, because I need to make sure that everyone is loved by someone else. I need to make sure that P4 is loved by someone else, P5 is loved by someone else, and P6 is loved by someone else. You can do this also. Maybe this P6 is loved by P5, this P5 is loved by P6, and maybe this P4 is loved by P6. So this is also fine. But the point is, if you want to make this true, then you need to put additional, at least minimum 3 additional arrows you need to put in the diagram. Let's see the next. This 15th expression is saying that there is some x such that for all y, x loves y. So it simply means that there is someone such that for everyone, there is some x, this x such that for all y, I can say this x loves everyone. So there is someone who loves everyone. There is a fixed person. There exists a fixed person who loves everyone. Okay, there exists x such that for all y, x loves y. There is someone who loves everyone. Remember, when you write like this, there exists x for all y loves x comma y, what it simply means? It simply means that there is someone such that for all y, there is someone such that for everyone, I can say that this person, there is someone, this A loves everyone. Okay, so this is the point, that someone loves everyone. So this expression means there is someone, there is at least one person, there is someone who loves everyone. There is someone who loves everyone. So this is what your expression means. Now, in this diagram, do you have anyone who loves everyone? You can see this P1 does not love P2. So this P1 does not love everyone. You can see this P4 does not love P6. So P4 does not love everyone. This P3 does not love P6. So this P3 does not love everyone. This P5 does not love P2. So P5 does not love everyone. The point is, in this diagram, there is no element who loves everyone. So I can say that this expression this expression is false. Why this expression is false? Because remember, this expression is saying that there is someone who loves everyone. Okay, and this expression is false. The reason is simple, that there is no element in this diagram who loves everyone. So very simple. Now how to make it true? So this expression, we already know this expression is false, but how to make it true? If you want to make it true, then what is the minimum number of additional arrows you need to put in this diagram so that this expression will become true? So to make it true, minimum number of additional arrows I want to put. Remember, this expression is saying that there is someone who loves everyone. Okay, we in this graph, we need someone who loves everyone. We need someone from whom there is arrow to everyone. This type of person we need, and we need this with minimum number of arrows. So if I put from P2, if I want to make sure that P2 loves everyone, then I need to put 5 arrows. See, from P2 I need to put arrows to everyone. Okay, so total 6 arrows I need to put. If I make sure that P2 loves everyone, then P2 loves P2, P2 loves P1, P2 loves P3, P2 loves P4, P2 loves P5, P6. So total 6 arrows I need to put from this P2. From this P4 I need to put 5 arrows because already P4 loves P3. So I need to make sure that P4 loves P4, P4 loves P1, P4 loves P2, P4 loves P6, P5, P6. So I need to put total 5 arrows from P4. But the point is, you can see that if you want minimum arrows, minimum how many arrows you need. So if you want minimum arrows, then that you will get either from P1 or from P2, because these two people are already love two people. See, this P3 already loves P1, P2. Similarly, this P1 already loves P1, P3. So these two people, this person, these two people, they already love two people. So they only need 4 additional arrows. Okay, so for example, what I can say that minimum 4 arrows you need. Minimum 4 arrows you need. Okay, minimum 4 arrows we need if we want to make sure that there is at least one person who loves everyone. What I can do, you can see P1 already loves P1, P1 already loves P3. What I can do, I can put this arrow, P1 loves P2. I can put this arrow, P1 loves P4. I can put this arrow, P1 loves P5. And I can put this arrow, means P1 loves P6. So this is what I can do. The point is, minimum 4 arrows I need. Minimum 4 arrows I need. What I can do, from P1 I can put arrows to P2, P5, P6, P4. This is what I can do. Or what I can do, I can put arrows from P3. So I need to make sure that P3 loves P3. So this arrow I need to put. I need to make sure P3 loves P5, P3 loves P6, P3 loves P4. So these 4 arrows I need to put. The point is simple, that this expression is false because there is no element in this graph who loves everyone. So this expression is false. This is saying that there is someone who loves everyone. So this is false. And to make it true, if you want to make it true, then you need minimum 4 additional edges. Minimum 4 additional arrows you need. Minimum 4 additional arrows you need. Either you can put arrows from P1 or you can put arrows from P3. But minimum 4 additional arrows you need. Remember, if you do this mistake, that if you don't put P3 loves P3, if you don't put this P3 loves P3, if you don't put that, then remember, then this expression will still remain false. So remember, you need to make sure that P3 also loves P3. So this is a silly mistake. If your answer is 3, if you are saying that answer is 3, then it simply means that you are not putting this self loop on P3. Okay, if your answer is 3, then it simply means that you are not focusing on this. Remember, there is someone who loves everyone. Okay, so this P3 should love everyone. This P3 also should love P3. Okay, so there is someone who loves everyone, including himself. Now let's see the last one, this 16th one. This is saying there is some x such that for all y, if x is not equal to y, then x loves y. What it means? It simply means that there is someone who loves everyone else. See what this expression says. There exists x such that for all y, if x is not equal to y, then x loves y. What it means? Let me tell you. It means that there is someone, okay, there is some x such that for all y, I can say there is someone, for example A. Now we are saying that for everyone for every y, this x, this y, and we are saying there is someone such that for all y, if x is not equal to y, then x loves y. Okay, I can say there is someone such that for all y, such that if x is not equal to y, if x is not equal to y, then x loves y. So you can easily notice that it simply means that there is someone who loves everyone. Okay, there is someone who loves everyone means there is some x such that for every y, if x is not equal to y, if y is other than x, then x loves y. What it means? It means that there is someone who loves everyone else. So I can say that there is someone who loves everyone else. There is someone who loves everyone else. So this is what it means. So this expression means that there is someone who loves everyone else. Okay, so in this you can notice, is there anyone who loves everyone else? No. You can see this P3 does not love P6. So I can say P3 does not love everyone else. Similarly, this P1 does not love everyone else. So this P5 does not love everyone else. This P5 does not love P4. So I can say this P5 does not love everyone else. Similarly, this P6, this does not love P4. So I can say this P6 does not love everyone else. The point is simple. In this, there is no person who loves everyone else. Remember, this expression means that there is someone loves everyone else. There is at least one person who loves everyone else. And I can simply say that this statement is false. So remember, this expression is also false. Okay, because there is no element who loves everyone else. Now, what is the minimum number of arrows you need to put in this diagram to make this statement true? So this expression is already false. We already know this expression is false because there is no element who loves everyone else. But if you want to make it true, then what is the minimum number of arrows you need to put? In this diagram, what is the minimum number of additional arrows you need? So remember, if you want to make this true, then you need someone who loves everyone else. So you can see this person P3, this already loves P1, P2. So this P3 will give you the minimum number of edges. So very simple. All you need to do, just make sure that P3 loves everyone else. P3 loves P5, P6 and P4. So I can say that if you do this, now you can see that P3 loves everyone else. So now there is someone, if you do this, if you put these three arrows, then now there is someone, this P3, who loves everyone else. So remember, to make this true, minimum you need 3 additional arrows. So what you do, just put 3 arrows from P3 to P5, P6, P4, and so that is the answer. So I can say minimum 3 additional arrows are needed to make this 16th statement true. So this is your question. I hope the complete question is clear to everyone. So please comment on this video if you understood all the 16 questions. There are total 16 questions in this. We have seen all of them, the detailed analysis we have done. I hope you understood this question. Okay, this is a Stanford question. This is a standard question, a very nice question. This covers many concepts. So if you understood all the 16, okay, if you understood all of them, then please comment and let me know. Okay, so please put a comment. That is very important. It will tell me whether you understood or not. And if you solved all the 16 questions by yourself, so that also you let me know. From 16, how many you did it yourself? So that also you tell me. Okay, so out of 16, how many did you solve yourself? How many were correct by yourself? So that also you tell me. So please put a comment on this video and let me know, did you understand all of them and how many did you solve before seeing the solution?